This is Euclid Book 4, proposition number 13, part 3. And as you can see here, this diagram is a complete mess. So what I decided to do was I made a BCF like this. I duplicated this triangle from B to C to F, and I duplicated this triangle from F to C to D. Okay, I duplicated them right here. And that way you could better see what I was trying to do. Now, I said that BC was equal in length to CD. And the reason for that is because it's two sides, okay, two sides of an equal angular and equilateral pentagon. When you have an equilateral pentagon, of course, all 5 sides are the same length. Therefore, BC and CD are exactly the same size. Now, obviously, CF and CF are exactly the same size because they're the same line. Now then, we said that BCF and CDF are also the same size. Hang on a second here. And the reason why BCF and CDF are the exact same size is because we bisected angle BCD. Okay? BCD. We bisected that angle there, and by doing so, we could say that BCF and CDF are exactly the same size. So now what do we have here? We have a side, angle, side. Side, angle, side. And by doing so, we can then say that these two triangles here are exactly the same size. By doing so, we can also say that FBC or CBF right here, this angle right here, is equal in size to CDF. This one is equal to this one. Now, we went on to say that angle CDE right here, CDE, is twice the size of CDF. Now, I went ahead and measured this. CDF is 52.5 degrees, and CDE is 105. Okay? So, we now know that CDE is twice the size of CDF. Okay. Now we can do a lot of substitutions. Remember, if you have 3 apples that are of a certain weight and certain size, and you take them out and you put in 3 oranges that are of an equal weight and equal size, then really you have not changed the scale weight at all. Okay, it's just like a pair of scales. If you have a 20-pound bowling ball and you take the 20-pound bowling ball off and you put a 20-pound turkey on the scales, it's still going to be 20 pounds. The way it works. All right. The first thing we established was that CBF and CDF were exactly the same size. Alright, CDE is twice the size of CDF. Now comes some substitution here. CDE is twice the size of CDF. Since we said that angle CDE was exactly the same size as angle ABC, which happens to be 105 degrees, then we can go ahead and say that angle ABC is twice the size of CDF. Now, we already said the CDF was equal in size to angle CBF. So what we're going to do is we're going to substitute angle CDF for CBF. And angle ABC is twice the size of CBF. Now, if we remove angle CBF from angle ABC, because you got here A, B, C, and we're going to remove CBF, CBF. We're going to remove that angle from this angle. In other words, we have a 105 degree angle. We're going to subtract 52.5 degrees from that. What do we got left? We got another 52.5 degree angle, and it's called ABF. I'll show it down here. ABF. So this angle here becomes equal to this angle here, and thus we have proven that angle ABC has been bisected by BF. And if we were to go through this whole rigmarole all over again, we could go on to prove, and you can do this for yourself, and if you ever want me to do it, I'll happily do it for you, but I don't think really need to do this. If you're really smart enough to do this, you should be able to do this quite on your own. But I'll do it if you need me to. Anyway, we can say that angle BAE, well, here's B, here's A, and here's E, and it has been bisected by line FA. We can say that now. Okay, FA bisects BAE. And we can go on to say, hang on, AED. Well, where's AED? Well, here's A, and here's E, and here's D, and it has been bisected by EF, which is what we needed to prove in the first place. Alright, I will tell you more in a future video, so stay tuned.